Hey everyone, and welcome back to the channel. Today, we're tackling LeetCode problem number 9, palindrome number. This is a medium difficulty problem, and it's a classic that often shows up in coding interviews. The goal is simple. Determine whether an integer is a palindrome. A palindrome, in case you've forgotten, is a number that reads the same forwards and backward, like 121 or 1001. But it's not as straightforward as it sounds, because we can't directly reverse the number as a string because of potential integer overflow issues. We need to think about this efficiently and cleverly. We'll explore a couple of approaches today, starting with a less efficient one to really understand the problem. Get ready to dive in and master this algorithm. Understanding with examples. Let's look at some examples to get a clearer picture. The number 121 is a palindrome because it reads the same forwards and backward. Similarly, 1001 is also a palindrome. However, 123 is not because it's different when reversed. Another example, negative 121 is not a palindrome because palindromes are typically considered positive integers. Consider the number 10. This is not a palindrome. Think about these examples for a moment. What patterns do you see? What approaches could use to solve this problem? Let's move on to explore some solution strategies. Brute force approach. One straightforward, albeit inefficient, approach is to convert the integer to a string, reverse the string, and then compare the original string to the reversed string. This is a brute force method. If the strings are the same, we have a palindrome. If not, then it's not a palindrome. However, this method isn't the most efficient because of the string conversions, which involves extra steps and memory. For extremely large numbers, the string manipulation could be slow. We want a solution that scales better, especially when dealing with large integers, and that's what we'll build up to. Optimal solution. A more efficient approach involves comparing the digits of the number from both ends simultaneously. We don't need to convert to strings. We'll use two pointers, one starting from the leftmost digit and the other from the rightmost digit. We'll compare the digits at these pointer positions. If they match, we'll move our left pointer one step to the right and our right pointer one step to the left. We'll repeat this process until the pointers cross each other. If all comparisons match, it's a palindrome. If any mismatch occurs, it's not. This method avoids string conversions, making it much faster and more memory efficient. Code implementation. Let's see the code in Python. We'll implement our optimal solution. First, we handle the negative number case, returning false because negative numbers can't be palindromes. Next, we extract the digits using modular arithmetic and integer division. We set up our left and right pointers. We can continuously compare the digits from both ends until our pointers cross. If a mismatch is found, we can return false immediately. If the loop completes without finding a mismatch, we know it's a palindrome, and we return true. It's that simple and elegant. Time and space complexity. Now let's analyze the time and space complexity of our solution. The time complexity is O of n, where n is the number of digits in the integer. This is because we iterate through approximately half the digits in the worst-case scenario. The space complexity is O of 1, which means it's constant, as we're only using a few variables to store our pointers and temporary values. This is a significant improvement over the brute force approach, which had a higher time complexity. Engagement break. Before we wrap up, I'd love to hear your thoughts. Did you find this explanation helpful? What other approaches did you consider? Don't forget to like this video if it helped you, and subscribe to the channel for more coding tutorials. Also, leave a comment down below and let me know what LeetCode problem you want to see me cover next. Your support motivates me to keep creating more high-quality content. Conclusion. In this tutorial, we successfully tackled the LeetCode palindrome number problem. We explored a brute force approach and then moved on to develop and implement a much more efficient solution with linear time and constant space complexity. This kind of